Okay, now I want to take us to actual modular arithmetic, which, like I said, is the key to doing computer arithmetic for signed integers. So the way that we're going to start is I'm going to look at an equivalence relation, which we're familiar with. A is equal to B, or congruent to B is the technical term, but I usually say equal. A is equal to B modulo n, okay? And what that means is that A minus B is a multiple of n, okay? So here are a few kind of equivalences, I guess, okay? Here's what we know. I mean, we've seen in this section that if A minus B is a multiple of n, that means that A is equal to B mod n, right? We proved that. That also means that n divides A minus B, okay? And what that means is that there exists a k, which is an integer, such that A minus B is equal to k times n. And that also means that A mod n is equal to B mod n, right? All of these are the same, all right? Now, something else that we know is that we're actually defining an equivalence relation. And we actually proved this from scratch when we were talking about equivalence relations. But all the results that we did kind of in this little unit actually show that very nicely, okay? So A equals B mod n really is an equivalence relation, okay? And that means that it partitions the integers into equivalence classes, all right? And the equivalence classes are the remainders because A equal to B mod n is only possible if A mod n, which is the remainder, is equal to B mod n, right? So what I'm really looking at is all the possible remainders when I divide by n, and there's n of those, right? There's 0, 1, 2, up to n minus 1, right? And the equivalence class is just me. The equivalence class of I is just all of the j's that are equal to I mod n, all right? Okay, so taking that, the equivalence class of A is the same as the equivalence class of A plus n, A minus n, A plus 2n, right? Any multiple of n, okay? And I also know from what we did in this section that the equivalence class of A1 is equal to A2, and the equivalence class of B1 is equal to B2, right? Well, that means that the equivalence class of A1 plus B1 must be the same as the equivalence class of A2 plus B2, right? All I'm really saying here is that A1 plus A2 mod n, right, is equal to A1 mod n plus A2 mod n mod n. Okay, right? That's where that comes from, right? They have to have the same remainder, modulo n, and the same goes for minus. The same goes for multiplication, right? So they're in the same equivalence class. Or if A1 is the same as A2, B1 is the same as B2 modulo n, then when I add them, I get the same modulo n. When I subtract them, I get the same modulo n. When I divide them, I get the same. Multiply them, I get the same modulo n. Okay, so what that means is that I can now start doing arithmetic on those equivalence classes, right? So I can define, and I want to be clear on this, these are the definitions, okay? This is not the usual times, okay? It's not the usual times operator, and here's why. These things are sets. You can't add sets, you can't subtract sets, you can't multiply sets, okay? But we're simply defining what it means to add these two special sets, which are equivalence classes. And we say, oh, if you want to add the equivalence class of A and the equivalence class of B, just add A and B normally, and then find out what is equivalence class. That's the result, okay? So that's what we mean by doing arithmetic on these particular sets. So for example, when n is equal to 5, then 2 plus 4, and I put the subscript 5 on that plus to remind us that that isn't the same multiplication, because in fact 2 is not the number 2, it's the set of 2, right? This is actually this is the same as saying the equivalence class of 2 with respect to 5 plus with respect to 5, the equivalence class of 4 with respect to 5 is equal to the equivalence class of 1 with respect to 5. That's really what we're saying, except we're being a little loose with notations. We say 2 plus 4 when we mean equivalence class, okay? And the answer is still just 1, right? Because 2 plus 4 is 6, which modulo 5 is 1. So the equivalence class of 1 is the same as the equivalence class of 6, right? Okay, and 2 minus 4, that's going to be 3, okay? Again, because it's minus 2, which modulo 5 is 3. 2 times 4 is going to be 3, because 2 times 4 is 8, which modulo 5 is 3, okay? So this is actually what we mean by modular arithmetic. Okay, and modular arithmetic is just doing the arithmetic modulo some number. Okay, and what I'm trying to tell you is that we're really doing arithmetic in these funny equivalence classes, right? But the results are the same as if we just do the arithmetic and then take modulo n, which is great because that means it's really super easy to compute.